All right, guys, here we go. Overview of the exam that the honors class had. And let's start with the first question. All of this is with no calculator. So here we go. So it says solve sine 5x equals 1. So the first move that I would do is I would write sine of 5x equals 1. Now remember, we can't do anything with that 5. You can't pull it out. You can't divide by 5, like, because it's sine of 5x. So that's it. Like, you can't mess with that. So next move, you're going to get rid of that sign. So how do you get rid of that sign? By doing the inverse. So I'm going to write, here's my second line. You're going to go 5x equals inverse sine or arc sine of 1. And then I add plus 2 pi n. Why do I add 2 pi n? Because if I go a full revolution on the unit circle, I am back at that same location. Does that make sense? Okay. So now I'm going to draw a unit circle really quick. I'm going to go, and then you ask yourself, where is sine equal to 1? And it only happens in one location, right here. Sine is the y value, right? So there it is. What angle is that? Pi over 2, yeah. So if we were in degrees, we would write 90, but we're in radians. So we're going to go 5x equals pi over 2 plus 2 pi n. That's the only place where this is equal to pi over. This is the only place where sine is equal to 1. Are we still okay?
Yes.
Okay. So now what I need to do is I need to get the x by itself. So I have 5 times x, so I'm going to divide by 5. Divide by 5. You can either divide by 5 or put the 5 next to the 2. It doesn't matter. It's the same. Divide by 5. So you have x is equal to pi over 10 plus 2 pi n over 5. So catch up to here.
Can we put the n on the side?
Yes. You can put the n on the sides. Hey, guys. You can put the n on the sides right here like that. All right. Next. Well, one answer, see how I'm only looking between 0 and pi over 2? So one answer is 1/10 of pi or pi over 10, because 1/10 of pi is smaller than half a pi. So anything that has 1/10 of pi is a possible answer. Maybe. That one doesn't have it, out. This one doesn't have it, out. Maybe. And then I guess letter F is a maybe. All right, next. Well, as long as I keep adding, I can keep adding what? 2 pi over 5. That's actually the period. If you keep adding 2 pi over 5, as long as I'm below pi over 2, you're fine. So I'm going to do common denominator. I'm going to multiply this by 2 over 2. By 2 over 2. So here's what I get. And I guess I'll just write a new line here. X equals pi over 10 plus 4 pi over 10 with an n on the side. We still okay? All right. Well, what if n equals 1? If n equals 1, I have x equals, see, look, this is 1 pi over 10. The denominators are the same, so that means I can add them. 1 plus 4 is 5, so I can write 5 pi over 10. Does that make sense, guys? Now, 5 pi over 10 reduces. 5 goes into 10 how many times? 2 times, so pi over 2. Pi over 2 is right on the edge of this domain, 0 to pi over 2. So pi over 2 is an answer, check mark. And pi over 10 is an answer if n is 0. See? If n is 0, you just get pi over 10. Do you see that? So, pi over 10 and pi over 2. How do we feel?
Better.
Okay. Can we go to question 2? All right. And I'm going to go slow. Stop me if something doesn't make sense. So you're going to stop me, right, Escamilla? Okay, stop me. All right. First move. Okay, no, we're good. LOL, miss. Cosine of 7x equals 0. So start with that. Next, I want to get rid of that cosine. So how do I get rid of that cosine? Inverse. So you're going to write 7x equals inverse cosine of 0 plus 2 pi n. I'm going to draw a unit circle. So what this means, that means cosine of what angle equals 0? And there's 2 angles. Right here, 0, 1. And right here, 0, negative 1. Remember that cosine is the x value. So the first one happens at pi over 2. And the next one down here happens at, perfect. And I'll slow down. So now I'm going to write 2 expressions. So I'm going to write 7x1 equals, and I'm going to write the first one, pi over 2, that's what our cosine of 0 is, plus 2 pi n, semicolon, to do the next line, 7x2 equals 3 pi over 2 plus 2 pi n. Are we okay so far?
Yes.
Okay. I want to isolate the x1 and the x2, so I'm going to divide by 7. Divide by 7, 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 divide by 7. When I say divide by 7, just put it in the bottom of the fraction. You could also say 3 pi over 2 over 7, and then do keep, change, flip, and you'll get it back in the same location. So here's what I get. x1 equals pi over 14 plus 2 pi over 7 with an n on the side. You prefer the n on the side, right?
Yeah.
Okay. Bless you. x2 equals 3 pi over 14 plus 2 pi over 7 with the n on the side. Are we still okay?
Yes.
All right. If n equals 0, there's my answer, pi over 14. And 3 pi over 14. Notice my domain is between 0 and 2 pi over 7. So you cannot add 2 pi over 7 to this because it would be outside of that domain. So there it is. And it is this one, pi over 14, and 3 pi over 14. Check mark and check mark. How do we feel? Okay. You feel okay? All right. Let's go to the next one. All right. This one right here. I saw a lot of funny business. Did you factor it, or did I write that you didn't factor it?
You just said this.
Yeah, you can't, because some of you were doing this. Some of you were moving the 1 to the other side, and you were going 2 cosine squared x plus cosine x equals 1. Was that you? Yeah, no, you can't do that. You can't, see, okay, why can't you do that? You know how in math we always equal everything to 0? Why do we always equal everything to 0? Because it's easy to find where you get 0 times anything is 0. Chop, what are you talking about? Don't write this down. Just listen. Just take this in. So if I were to tell you x plus 3 times x plus 2 equals 0. Well, look how easy it is to find. The only way you can get a 0, is if x equals negative 2. Negative 2 plus 2 is 0, and 0 times anything is 0. And if x equals negative 3, negative 3 plus 3 is 0, and 0 times anything is 0. See, but a lot of you guys are doing this. You guys are like, oh, let that equal 1. Well, now that just became so much hard, because now you got to think of a number times another number that's going to give you 1. What is it? Is it 2 times a half? Is it 4 times 1/4? Like, is this one 4 and this one 1/4? Is this one 10 and this one 1/10? Like, do you guys see what I'm talking about? So it's so much harder. So that's why you only equal it to 0, because it's easy to find numbers that multiply to give you 0. It's 0. 0 times anything is 0. So stop with let's move it over here. Oh, that equals 1. That's how I know you're a robot. And I mean that with love, miss. Because how do I know you're a robot? Because, I do it with this all the time, so why can't I do it with anything else? Equal it to 5? Oh, that equals 5. Like, no, that's not how it works. This times this equals 5. Now you're going to have to think, like, if this expression is 5, the other one is 1/5. Look how much harder it's going to get. Do you see what I mean? Yeah. So that's why we equal it to 0, because that's simple. What times 0 gives you 0? Well, 0, so just set the expression equal to 0. Don't be a robot. So stop equaling it to anything else other than 0. Okay, so let me go back to this. Sorry about that, guys. I felt it needed to be said. All right. So this right here. This is just like or similar to when you were in Algebra 2, when you had 2x squared plus x minus 1 equals 0. If we cannot factor this, and I mean this with love, if we can't factor this, then game over, you're done, you're cooked, as you guys would say, because you can't solve it. So how would you solve this one when you were in Algebra 2? Well, when you were in Algebra 2, you could do the quadratic equation if you wanted to, but all these are factorable. So what is it, child? What do you mean by factorable? That means I can split it up like this. There's only one way to get a 2x squared, 2x times x. And there's only one way to get a negative 1, 1 times 1. So now I got to figure out which one is it. Well, the bigger number has to be positive. So 2x times 1, this has to be the plus 1, and this has to be the minus 1. Chop, why? Look, 2x times x, that's that 2x squared. 2x times positive 1, that's that positive 2x. See? 1 times x, that's that minus x. Negative 1 times positive 1, that's that minus 1. When I combine like terms, 2x squared plus x minus 1. See? See how we got the same thing? Okay. What's up, Houston? Yeah. What's up? So now that I know that it looks similar to this, I'm going to rewrite this. So here we go. 2 cosine x minus 1, close open, cosine x plus 1, close, equals 0. And here we go. I'm just going to go cosine x plus 1 equals 0. So that means from this one, I can tell you that cosine x has to equal negative 1. On the unit circle, cosine x is negative 1 right there. What radian is that? You know what radian that is, guys?
I'm trying to.
Oh, you're good. I think I heard you say it. What is it? Yeah, fine. All right, now look at this. I'm almost done, miss. Let me just do this real quick. 2 cosine x minus 1 equals 0. Move the 1. 2 cosine x equals 1. Divide by 2. Cosine x equals a half. On the unit circle, cosine x is a half right here. 1/2 comma square root of 3 over 2. And right here. 1/2 comma negative square root of 3 over 2. Do you remember this coordinate, this radian right there? Okay, what's this one? 5 pi over 3. There it is. So this one happens at x equals pi over 3 and 5 pi over 3. Okay, let me see.
I figured it out.
Oh, you got it?
Yeah, it was the they had already given me the first derivative.
Oh, so there it is.
So I just had to do this.
Perfect. See, you got it, miss. Oh, don't leave me hanging, Houston. Don't leave me hanging.
Oh, I didn't see it. My bad.
Okay, wait, on this one though, we can divide by 2. On like the first fraction.
Okay, because this is different. This is 2 times cosine x. So you're saying like on this one you can divide by 2. Yes, because that 2 is not in front of the x. See, so this is 2 times, this is a coefficient now. So that you can divide. But if the 2 would have been in front of that x here like that, then you can't divide.
Even though it's like.
Because, okay, right here it's a coefficient. It's 2 times cosine x. But if it were in here like this, if it were, it's not. But if it were like that, that means it's cosine of 2x. And 2x is together. And you have to get rid of the cosine before you can divide by 2. If it were on the inside.
So we can't like turn it into 2 cos x if it's like just near x. Like we can't move it to the outside if it's like with the.
If it's with the x.
Like, at all.
At all. Because it's the argument. Right? So I'm going to do an example for you. So let's say I have this. Cosine of 2x equals 1/2. Okay, well, I want to solve for x, right? This is just a new example. New example. Well, how do I get... You cannot move that 2. That 2 is part of the x. So you got to get rid of the cosine. How do I get rid of the cosine? Inverse. So you're going to go semicolon. And I'm going to go 2x equals inverse cosine of 1/2 plus 2 pi n. And now this, well, this is this part. See how we have cosine x equals a half? You can do... So this is this. You see that? So I could go from here. You say 2x1 equals pi over 3 plus 2 pi n. Semicolon 2x2 equals, what was the other one? 5 pi over 3. If it was like this. And now you can divide by 2. Now you divide by 2, 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 divide by 2. Do you see what we're doing? So now x1 equals pi over 6 plus pi n. Semicolon x2 equals 5 pi over 6 plus pi n. If it were like that. See? So thank you for asking, miss. Do you feel yourself getting stronger in math? Okay. So put that in your mental note, and we're never going to get those wrong ever again. This is good stuff. No, you have no idea how happy I am. Keep asking me these questions, miss.
Okay.
I love it. You're going to be math life AF, miss. No, we are. Okay. Should I not say that? We're Math Life, right? Okay. All right. You guys ready for number 4? Hold on, Ms. Vega. Okay. You're gonna bring it back? Okay. You tutoring? Who are you tutoring or what? Oh. Oh, so it's for you then. It's not for anyone. Oh. Are there any 6th graders? Okay. Next time I'll bring pizza, guys. I didn't have enough time to bring pizza today. But next time if I remember correctly, I'll order some pizza. Huh? Yeah, Mia Cruz is the one that usually goes to get it for us. All right, ready for question 4? All right, so I have something. I have 1 over 1 minus sine theta plus 1 over 1 plus sine theta. And I'm trying to add them. When you have 2 fractions, how do I add 2 fractions? I got to find a what? Common denominator. So on this one on the right, I'm going to multiply this by 1 minus sine theta over 1 minus sine theta. And this one on the left, I'm going to multiply by 1 plus sine theta over 1 plus sine theta. When you do that, here's what you're going to get. Maybe put parentheses here like that. So you guys can see this is like the difference of squares. When you do that in the numerator, you're going to get 1 plus sine theta. And in the bottom, you're going to get 1 plus sine theta times 1 minus sine theta. You're going to get 1 minus sine squared theta. I did take a shortcut. Are you guys okay with that? Or do you want me to explain how we got the 1 minus sine squared? I don't mind. Explain it? Okay.
Yeah.
So
Because it's just like the multiplying of it's just a negative.
Yeah. I'll do it here on the side. So this right here, the denominator, it's like doing this. Watch. 1 plus sine theta times 1 minus sine theta. Look. 1 times 1, 1. 1 times negative sine theta, negative sine theta. Sine theta times a positive 1, positive sine theta. Sine theta times a negative sine theta, minus sine squared theta. Look, these here in the middle, this negative sine theta plus sine theta, they zero each other out. And you just get 1 minus sine squared theta. And that's what this is in the bottom. Do you see how we did it? Okay. And I'll slow down. There's that plus. 1 times 1 minus sine theta is 1 minus sine theta. Over again, I'm going to get a 1 minus sine squared theta. Are we still okay? Now that my denominators are both the same, I can add them. So here it is. 1 plus sine theta plus 1 minus sine theta all over 1 minus sine squared theta. So catch up to here. Now check it out, guys. I have a positive sine theta in the numerator and a negative sine theta. What's going to happen to those two? Bam. What is 1 plus 1? So I have 2 over 1 minus sine squared theta. So I'm looking for that, and I don't see the answer. So immediately you should be thinking, I feel like I did everything right. You see this 1 minus sine squared theta? I can substitute that with something else. Do you guys remember? The Valentine's formula. Cosine squared plus sine squared equals 1, right? Look what happens when you move that sine squared to the right. Cosine squared theta equals 1 minus sine squared theta. Do you guys see that? Yes. So that means I can substitute 1 minus sine squared theta with what? With cosine squared. So I'm going to write 2 over cosine squared theta. So catch up to here. And I still don't see the answer. But notice the cosine squared is in the bottom. And we know, here's my little side note, 1 over cosine squared theta is the same thing as secant squared theta. So what am I going to do to this 2 over cosine squared theta? This is the same thing as what? 2 secant squared theta. There it is. What do you guys think?
It makes sense once you can see it all out. But when it's like trying to do it, it's like I don't know how to start it. That's my problem.
Yeah, start with, whenever you see a fraction like this with a plus, start with like, okay, I have two fractions. I need to get a common denominator to add them. You know what I mean? So put in there always whenever you have two fractions like this, start with common denominator, and that's how we're gonna start. All right. You guys ready for the last one here? Okay, here's how I would do it. I see a 1 plus tan squared, and immediately that's what I'm gonna focus on, that 1 plus tan squared. So I'm gonna be like, well, I know that cosine squared theta plus sine squared theta equals 1. The only way to get a tan squared is if I have sine squared over cosine squared. So that means I'm gonna divide all of these, and maybe you already have it in your little formula chart, but I like to derive it from scratch. So here it is. I have 1 plus tan squared theta equals secant squared. Ask me, ask me.
Why does it not just cancel out?
Oh, it does. Cosine squared over cosine squared is just 1. See, I have the same thing over the same thing. So when you cancel, it doesn't like go away. That's just a 1. And that's for anything. Watch.
Okay, it's like it's divided by itself.
Yeah. So like I said, I don't want you to be a robot. So if you have 5 over 5, that doesn't go away. It's 1. 10 over 10, 1. Cosine squared over cosine squared, 1. And don't worry, I'm going to prove it to you. Check it out. How am I going to prove it to you? Like this. Second, memory 712. I'm going to prove it to you like this. Look at y. I'm going to go 5 over 5. Maybe you can see this one's just 1 immediately. That's a 1 job. I know that. All right, let's do x over x. See, I have the same thing on the top, same thing on the bottom. Let's do cosine squared over cosine squared. So we can prove to you, parenthesis, cosine x, close, squared. This is how you say cosine squared. We can't put the squared after the s, so you gotta open parenthesis, type in cosine x, close it twice, and then put a square on it. So there it is. See how they're all 1?
Yeah.
Look, check it out. Table. They're all, well, it says error because you can't divide by 0, but look, they're all 1 all the time. Isn't that cool? Are you not entertained? So it's always 1. Oh, are you entertained? Yeah, see, it's always so this right here that I'm circling, we're not robots. This right here is always just what? 1. See? Now check it out. Look what I got. I got a 1 plus tan squared right there. And what does it say that 1 plus tan squared equals? Secant squared, yeah. And then look what I'm going to substitute. So I'm going to substitute that 1 plus tan squared. I'm going to substitute that secant squared. So I'm going to go cosine theta times secant squared theta. So do that first. Look at this little side note. Don't worry, I'm slowing down. Look at this little side note, and it says that 1 over cosine squared is equal to secant squared. Do you see that? So that's what I'm going to substitute again. So I'm going to go cosine theta times 1 over cosine squared theta. So catch up to here. Now that I have it looking like this, oh, buddy. Trying to get this border to come out. There we go. Now that I have it looking like this, look at this. I can cancel one of these cosines with one of these because that says 1 over cosine squared. See? And now this will just be 1 over cosine theta. Oh, okay. And 1 over cosine theta is just what? There it is. Yeah, we'll see. We'll see what's up. No, you're good. I caught you on video. So there it is. Secant theta. Does that make sense?
Yes.
Did all this make sense?
It did, actually.
Okay. What's up? Hit me.
Why didn't we divide it by distance?
Where do we go?
I knew I
Oh,
heard
because
you.
you see how that one plus that squared?
Across the hall.
I wanted to get that. So divide everything by cosine squared. Get the 1 plus x. 1 plus x squared. So that's like, the only way to get a tan is to get x over cosine squared. Maybe you don't have to do that if you already have this formula known, like you already know it. Or you don't want to put that square as distance squared. But if you don't know that, well, that's how you can derive it. Trying to get it to look like this, like it's, you know what I mean? Yeah, no, keep hitting me, guys. All right, there it is. We did it. I'm gonna upload this to